Okay, so let's just summarize what we've done. So this is a complex number, and a complex number is made up of a real part and an imaginary part. So the 3 is real, and the imaginary is 7. Easy, because you can see that the 7 has an imaginary sign on it. It's got an I there, so you know it's imaginary. And you can graph these onto a Cartesian plane. So we know with a normal Cartesian plane, we have x and y. And y. And so if you have a coordinate, say here, let's say you have a coordinate over here, that's 2 and 3, then it means that the x value is 2 and the y value is 3. So what we also know is that from trigonometry, we can, if we draw a line to that value, from the origin to that, we can drop a perpendicular down here and we get right angles. And so if I was to put an angle in here, theta, then from our trig triangle, which I'm going to draw here, we have opposite of the angle is O and A and H. And so if we have sine theta, that will be opposite over hypotenuse. Cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. Now in complex numbers, it's this tan theta is one of the more important ones, because tan is the thing that has the opposite and the adjacent, which when we look at this x and y, so when we look at this triangle in the Cartesian plane, the y value, the y length here, if that's 3 and it goes all the way to the x-axis, this length is 3. So that length is 3. And if we look at the x-axis, that length is 2.
2.
And so we could have tan theta is equal to
3 over 2.
3 over 2, good. 2. Okay. So now with imaginary and real numbers, what we do is we can plot those on a graph as well. So the real is the x value. So we can just say this, we can just make that an R. And we'll just, in brackets, real, just so that we remember. And the imaginary is y. So that would be the I-axis. I'm just going to... Okay, and the way I remember the imaginary is on the y, is imaginary at the end has a y. So just remember that. Imaginary is a y-axis. And so I can plot the 7 on the y-axis. So let's say that's 7. And then the 3 is on the x-axis. Yeah. And so just like in the normal Cartesian plane, I can have an angle. And so we know that tan theta is equal to 3 over 4 over 7. Okay. Now, just remember in this one, it was tan theta was y over x. So let me just put that over here, y over x. And tan equals y over x. And then the hypotenuse, when we're looking at a Cartesian plane, is r, because it goes in a circle like that.
Yeah.
So we can think of it as an r. And it could be anywhere. Your r could even be here. It's always going to be the same.
Yeah.
So with this, with the real numbers, just think of the z as the r.
Wouldn't the 10 be the other way around?
Correct.
7 over 3.
Yes. Very good. Okay. 7 over 3. Okay, so we have the imaginary and the real part, and we know that z is our r. So we could say,
Yeah.
now z, the terminology, they call it, it's the modulus. And so from Pythagoras, we know that this z here would equal the square root of 7 squared plus
The 3 squared.
3 squared. Good. And so we know that the z is the value from the origin to the point where we have the two real numbers. So when you see a and b, so sometimes they give it in like weird terminology. Just think of it like this. So they'll often write it as, to try and make it inaccessible to people and more confusing, is they'll often just give it as a definition. And so you might see this. You might see z equals a plus bi. And so the length of a, the length of z is equal to the square root of
a plus a to the power of 2 plus bi, well, b to the power of 2.
Perfect. You got it. Okay,
So
excellent.
then, a stupid question.
So
the tan theta, does that calculate the angle of the does that calculate the angle?
yes, it will calculate the angle, but you need to do, so we know that tan theta, so I should actually put a theta here, is equal to 7 over 3. That's not immediately going to give you your angle, because you need to put in, because tan is on the other side of the 7 over 3, you just write it in your calculator as tan, and imagine the tan, if the tan went to the other side, it would go into the bottom. So we write it as tan to the minus 1 on that.
Minus 1, and then times 7 over 3.
With 7 over 3 in brackets. Good.
Okay, and then you just use the calculator to get that and then give you the angle.
Absolutely.
Okay.
Cool. Is that all good?
Yeah.
Excellent.